Hi guys, welcome. In this video, I'm going to explain container and I'm going to brief about Docker images, and Docker architecture. Before going to that, let's get understand what is container. A lightweight approach to virtualization, an operating system level virtualization. It is a super minimalistical virtual machine that are not running on an hypervisor. Only provides a bare minimum that app requires to run and function. Actually, we can see the difference between the VM and the container. VM, it's basically runs on its own OS provided an high degree of isolation, but it takes times to start. Whereas container is a lightweight virtualization which shares the same OS and start fast. So Docker. Docker is an open platform for developers and system admin to build, ship, and run distributed applications. It consists of a Docker engine, a portable, lightweight runtime and packing tool, and a Docker Hub, a cloud service for sharing application and automation workflows. Docker enables an apps to quickly assemble from the components and eliminates the friction between QA, development, QA, and production environments. As a result, it can ship faster and run the same app unchanged on laptops, data centers, VM, and any cloud. Docker is a container manager, a build system, a lightweight virtualization. Images may be built from sources based on Linux and names and C groups. It has a simple Docker file called DSL. Using one single file, we can kick off a Docker apps. A massive copy on write, a REST API. Docker provides a wonderful feature called a REST API. Using this REST API, people can kick off or pull information or run the Docker engine. And Docker has some immutable images. And Docker Engine API is control the Docker engine. Instant deployment and plugin API suitable for microservices. That's one process, one container. Registry API. It has an option to push, pull, publish images. And it is an immutable architecture. And we also have a Swarm API that managed cluster on a Docker machines. Docker container is has its own temporary file system layered over an immutable file system. It's fully writable, a copy on read write. A drop on a container is ends of life unless a commit is made. A network has its own network stats and it has its own private IP address. By default, it starts with 172.17.series. It has its own process group and it has one main process launched whenever inside the container. All sub-processes are signal killed when a main process exists. The native installation requires a Linux kernel of 3.8. Docker machine has its command provisioning for managing Docker nodes. In the local, it can be deployed either in the local virtual machine or remotely or into any cloud services. So I'm going to explain about the Docker architecture. How Docker architecture really looks. Docker has a client server architecture. It has a Docker client and a Docker daemon. Docker client consists of various commands, basically Docker build, pull, run. When you initiate any command, it sends to Docker daemon. The communication between the Docker client and the Docker daemon is carried out through a sockets or a RESTful API. Docker daemon creates and runs and distributes the containers based on the instructions from the Docker client. The Docker client and the Docker daemon can be on the same host or a different host. Docker images. Docker image is nothing but it's a golden template. An image consists of an OS, Ubuntu or CentOS, etc. An application installed on top of it. These images are called base images. Base images is the building block of a Docker container from where the containers can be created. An image can be built from a scratch using a Docker inbuilt tools. You can also use a Docker image created by another users from Docker public registry or a Docker hub as based on the image or from any content from your containers. Docker as its registry, it contains either a public registry or a private registry. Registry is nothing but it used to store the Docker images. Images can be pushed, pulled from Docker registry from launching a container. So public registry, it contains officially Docker images used to create images. Private registry created by user for storing private Docker images in your data center. You also create a private registry in a Docker Hub. In the next video, we will deal how to install Docker on CentOS 7.4. Thank you folks. Let's go on to the next video.